Hello, welcome back to this series exploring the property of shapes aimed at Key Stage 3 students up to A-Level students. So in this episode we're going to look at triangles. So last episode we looked at one-sided shapes which were circles. This time we're going to look at a three-sided shape, the triangle. And triangles therefore come up in the GCSE syllabus, those come up in the A-Level syllabus, and if you go into any form of engineering, triangles are an important part of those courses. So today I'm looking mainly at the properties of the triangles, namely the area. So first of all we should talk about what the different types of triangles are. So common to all triangles, other than the fact they have three sides, is they also have three internal angles, and the word triangle actually means three angles. And the sum of the internal angles always totals 180 degrees. However, if you do relativity in physics, where you get warped space-time, then your triangles get warped and this statement no longer holds true. But in general maths and everyday use, triangles have an internal sum of their angles which is 180 degrees. And you'll come across four different types of triangles. And most people would start with equilateral, but the way of my thinking about this is we're going to start with isosceles triangles. So an isosceles triangle has two sides of the same length, which I've called A here, and a third side, which I've called B. So you have two sides that are the same and one side which is different, which means that two of the angles made to the base, are the same, and I've called those alpha. And you have one different angle, which I've called here theta. And the height here, the base of it is I've called the actual B. That's why I've called this dimension along the bottom B, because I'm calling that the base. The base is any of the sides which forms a horizontal. And if you go from the horizontal to the highest point of any triangle, you get the height, which I'm calling H here. So a very special case of isosceles triangle is the equilateral triangle, and this is where all three sides are the same length. So in this case, all three sides are equal to B. So we still have the base at the bottom, but we could flip this triangle onto any of its sides and it would look exactly the same. So it's got three angles of symmetry going through it, or three lines of symmetry. Again, we've got the height H, and because all the angles now have to be the same because the lengths are the same, we can divide that 180 by 3, so each angle is 60 degrees. Next up, we have the scalene and right angle triangles, and a right angle triangle is a special case of the scalene triangle. So we've had all angles and all sides are the same in the equilateral triangle. We've had two angles and two sides are the same in an isosceles triangle. In the case of a scalene triangle, all the angles and all the lengths of the sides are different. So in this case we have different sides of A, B and C, and angles of alpha, beta and theta. We still have the H on the side. In the special case of a right angle triangle, it's a scalene triangle where one of the angles is equal to 90 degrees, which means that the angle, or the side which is at 90 degrees to the base, then becomes the height of the triangle, and then you'd have an angle which is 90, and in the other two cases, theta and alpha are the angles. So those are the properties of that's what a right angle triangle looks like. So something that you have to know throughout all these course syllabuses is the area of the triangle, and it's given as half the base times the height, and that is sometimes written as BH over 2. But the thing that doesn't often get explained is where this formula comes from and why it applies to all these shapes. So in the rest of this video we're going to look at a visual way of coming up with this formula. So we're going to start off with showing that the area is half the base times the height of a right angle triangle. So I'm going to start off with this rectangle with a base of B and a vertical height of A. So A is also equal to H. So the area of the square of the rectangle, so the area of the rectangle, which I'll symbolise as a box, is equal to AB, which is also equal to HB, because I can substitute the height of this for A. Now, if I divide this rectangle in half along the diagonal, I'm going to end up with two equal triangles. So the area of this triangle has to be equal to half of the rectangle. So in this case, we're going to have the area of this triangle, trying to make that look like a right angle triangle, is equal to half HB, and because this is a multiplication, we can swap the order of this, so this is half the base times the height. So we can do a nice visual representation of this right angled triangles. But what happens if it's a scalene triangle? So with a scalene triangle, we're going to start off with a box again. This time I've changed the base of the box to be C. The height is still A. So let's draw a scalene triangle in it. So I'm going to draw my triangle so it looks like this. So it's going up to the corner. I'm going to call this B, and I'm also going to call this length here B as well. So I basically said that 2B is equal to C. And now I can start showing you the area of this triangle. So the area of this whole box, AC, which I've written here, is going to be equal to the area of this blue triangle, the area of this green triangle, and the area of the red triangle, which is the formula I'm trying to find. So let's first of all look at this blue and green triangle. You can see they're both right angle triangles, and I've just shown you that the formula for a right angle triangle is half the base times the height. So we can actually fill this in. So if we start off with the green triangle, this is going to be the height. So we start off with the half. The base of this triangle I'm going to take as this top length here. I'm just going to flip it over. So it's half C multiplied by the height, which is A. This is going to be added to the area of the blue triangle, which is half the base, which is B, multiplied by A. And this has to be then added to the red triangle, which is what we're trying to find out. So I'm just going to call this capital A and then draw a picture of the triangle to symbolise this. We can now start bringing these fins over to the other side. So we're going to start off with, I'm going to keep this all in black from now on. So we're going to have AC minus a half AC minus a half BA is equal to A triangle. So the can also now start looking at what this actually means. So this B here can be replaced with AC. So this is the same as doing C over 2. So we can say that this is equal to AC minus a half AC minus a half C over 2A. Or this can all combine together to be the equivalent of a quarter AC or CA. So we can take this away. So the area of the triangle is equal to AC minus a half AC, which is a half AC, minus another quarter AC, which takes us down to a quarter AC. However, this is also equal to a half. We can replace this C with the B, so that's a half, half C. So we can replace this with a half times a half of C, and we can replace the A with the H. This would give C is equal, or half C is equal to B. Therefore, this bit here is equal to B. Therefore, we have a half BH, and we've shown that the area of a scalene triangle is actually half the base times the height. So we're showing that that formula holds. Finally, we're going to show that the area of an isosceles triangle, and therefore an equilateral triangle, is half the base times the height. So let's imagine we have a square of lengths B and B. So the area of the square is equal to B squared, which is equal to B times B. If you put a dot in the centre and we draw our triangles up to this, replacing pens, and we so have 4 triangles. All these lengths are going to be the same, and therefore we're going to have the area of the square is equal to 4 times the area of the triangle. So we can now say that the area of the triangle is equal to the area of the square divided by 4, which is equal to B times B all over 4, which is equal to a half multiplied by a half of B multiplied by B. And if we look at this height here is equal to half B, because this point is halfway along the height. Therefore, we can say that we replace this half B with H multiplied by B, which is equal to half the base times the height. So this is another visual way of just checking that your area for your triangles applies to isosceles, equilateral and scaling triangles. So hopefully you'll find that useful, and if you like this video please subscribe, and we'll cover more shapes next week.